Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So today we're going to continue on the tutorial on chapter 4. So let's look into the first example that we're going to discuss. So obtain the line current in the three-phase circuit of figure below. So if you look at this circuit here is a YY system, YY circuit. So for this question we need to find IA, IB and IC, which is the line current. So the best way to solve it, we try to simplify the circuit first. So it's first we try to find IA. So IA, we can draw the circuit like this. So this is IA and this is basically 440 and this is 6 minus J 8. So this is so if you look at this, is basically a VAN lah. Okay, so this is VAN, so it's between A and neutral, line A and line neutral. So to find IA over here, so we can use A V equal to IR, so I is equal to V over R. So for IA, if you look at the summary in the slide, the equation should be VAN over the impedance of the circuit, so over Z ZY lah, we call it ZY here. So 440 divided by 6 minus J8. If you use the calculator, you will get 44 angular 53.13 degree ampere. Okay, so once you get the current of A, you can basically find the IB and IC. So IB is basically IA angular minus 120 degree and IC is IA angular plus 120 degree. So if you look at this, it's basically you just get the magnitude over here and the phase. So the phase 53.13 minus 120, so we'll get minus 66.87 degree ampere. And for this part IC, for 53.13 plus 120 degree, so this is 44 angular, so if you plus, you will get 173.13 degree ampere. Okay, hope you understand. So basically you can refer to the summary from the slide. So this is the summary from the slide. So there's a equation that already mentioned here, so you just refer to this part, and this is basically YY system or circuit. There's also Y delta, delta to delta, and also delta to Y. So you just refer to this summary in the slide. Okay, let's look into this question. So the question asks to obtain the line current in the three-phase circuit of figure below. So if you look at this, is a Y to delta system. Basically you have to simplify the circuit to make it easier for you to analyze it. If you look at this, this is not a cross, it's not connected. It's basically just as a C to C and B to B connection. There's no connection over here. So we have to simplify the circuit a bit, because for this circuit we have to use mesh analysis to solve this question. So let's simplify it first. So we have a delta, and we have an element over here, and then we have a delta. So this is where we get confused. So if you look at this, the first loop is basically over here from A, and then B to B over here. So basically this is A, this is A capital, and this connection here is basically B and B. Okay, so you the loop is like that. It's not, the loop is not A C C. This is A B B, and then the outer is over here, which is the C and C over here. Okay, so this is 100 angular minus 120, this is 100, and then this is 100 angular positive 120. Okay, and over at the middle here I forgot to put the elements 1 plus J2, so it's the same. This is 1 plus J2, and this is ZL. So ZL is equal to 12 plus J12. Okay, so I hope you understand how to simplify it, because we're going to do the mesh analysis. So to do the mesh analysis, we need to identify the loop first. So this is, you can put it I1, and then this is I2, and then this might be I3 lah. Okay, so to analyze it, first we need to make an equation for mesh 1. So for mesh 1, it goes here, so we need to put the polarity plus minus plus minus. Okay, so the polarity, it goes to minus 100, and it goes to here ZL, and then another 1 plus J2, and then goes to this source. So we can write it down as 1 minus 100 over here, because it goes to the minus first, and then this is minus, the equation, I think the polarity here is wrong, because it should be like this. It should be like this, minus, this is minus, this is plus, because this should be positive and outside is negative. Okay, it couldn't be like this lah, it's not possible. Okay, if it's all minus, it's minus inside. Okay, so this is all, this is all minus lah. This is minus, this is plus lah. Inside is minus, because usually this is N lah, right, the neutral line. So negative, all is share with the same polarity, negative, 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 so outside is positive. So that's why this is positive 100 angular minus 120, and then we have 2 element here. We can write it down as, I think it's better to make it 1 by 1, and then we have a ZL. This is times I1, because it's in the I1 loop, and then we have ZL here, which is 12 plus J12 I, it's over I3, and then plus the last one is this one here, which is 1 plus J2 I1 minus I2. Okay, because it share the loop with I1 and I2 here. Sorry, I forgot about this part here, because it's also share the same current. Okay, So for this part here, I forgot to minus it. So basically I1 minus I3, because it share with I3 and I1. And then another one is this element over here, 1 plus J2 I1 minus I2 equal to 0. Okay, so that's how we write the equation. Then we can simplify it. So I1 we have, I1 we have this one, this part here, and then this part here. So we can add it up, where we'll get 14 plus change color, 14 plus J 14, 16 I1, and then we have I2 over here, which is this part here. So it's minus 1 plus J2 I2, and then I3 is over here, which is will be minus 12 plus J12 I3 equal to this part. So this part here, if you add it up, you will get in rectangular form 150 plus J 86.6. So this will be your first equation. Okay, so for the next question, we try to solve the mesh 2, which is at this part here. So there's a loop over here. So we will get first is minus 100, angular 120, which is this part, and then it goes to here, another minus 100, angular negative 120 degree, and then it goes to this element here, which is plus 1 plus J2 I1 I2 minus I1. Okay, and then it goes to ZL, so plus ZL is 12 plus 12 plus J12, which is I2 minus I3, because it is between the loop I2 and I3. And then the last element is this part here, which is plus 1 plus J2 I2 equal to 0. So if you simplify it, let's look at the I2 first. I1, so I1 is over here, I2 is over here, and I3 is over here. Okay, so once we know where is it, so it's easier for you to look. So I1 basically is minus 1 plus J2 I1, and then we have a I2 1, 2 and 3, so it is positive. So if you add it up, you will get 14 plus J is 16 I2, and then last 3 is I3, which is minus 12. This is 12. Okay, 12 plus J12 I3 equal to, so you have to add these two up. So if you add this up, you will get 0. Wait, let me check. Let me calculate it first. Sorry. So basically this polarity also should be minus and plus. So this should be minus 7. So the same as this part here lah. So at the neutral it will be minus polarity, at the outside it is positive, so this part should be positive, so here it should be positive, right? So if you look at the I2, it goes to positive first, so that's why it's positive, and then it went through this current voltage source, so it goes to the negative polarity first, so that's why it's negative, and then so on. So that's why you will get here is minus J173.2. okay, so this will be your equation number 2, and we need to find the equation number 3 at the loop I3 here. So for the loop I3, mesh I3, we look at this part here, so it should be ZL, which is 12 plus J12 I3, and then it goes to this part here, plus 12 plus J12 I3 minus I2, plus over here with this part I3 minus I1, 12 plus J12 I3 minus I1 equal to 0. So if you simplify it, so I1 is over here, I2 is over here, I3 is this part. Let me circle it. Okay, from here it's much easier, we can simplify it. I1, which is minus 12 plus J12 I1 minus I2, which is the same, 12 plus J12 I2 plus, so this is 12 times 3, we get 36. 36 plus J36 I3 equal to 0. Okay, so this will be your third equation. So once you get these three equations, which is over here, 1, 2, and 3, you can use the Cramer's rule, insert all the value, and you can get the value of I1, I2, and I3. So I1 is basically is what? IA. I2 is basically IC. So is it IC or minus IC? Let's look back. So if you look at this circuit here, IC should be like this, right? But the current is going, we draw the current opposite to IC, so this basically I2 is negative IC lah. Okay, I1 is this is IA, so the same polarity, the same direction of I1. Okay, and IB is here, so IB basically equal to I2 minus I1. Okay, so this is IB. Because what? Because if you look at this current flowing is the same current as I2, but it is between I1 and I2, mesh I1 and I2, so that's why we minus I2, we do this calculation I2 minus I1. So I1, which is IA, you will get 12.8 angular minus 50.19 degree ampere. I2 you will get, or IC you will get 12.8 angular 69.81 degree, and lastly IB 12.8 angular minus 170.19 degree ampere. So that's is the answer for this question. Okay, let's look at another example. Three 230 volt generators form a delta connected source that is connected to a balanced delta connected load of ZL equal to 10 times J8 ohm per phase as shown in figure below. So we need to find the value of I AC current of AC, and then value of I BB. Okay, so let's try to solve this question. Okay, let's solve IAC first. Try to find the IAC. Forgot to switch on my pen. Okay, so IAC is should be over here. IAC, so there's a capital letter and normal letter, so this is IAC, which flow through this ZL. So we know ZL is 10 plus J8. So to find the IAC, you can use V equal to IR. So VAC divided by R, which is this ZL. So now ZL, we know the value. We need to find the voltage across AC here. So if you look at this circuit here, basically the AC, the voltage of AC here is basically parallel to the voltage AC over here. There's a small letter. So if you draw back, the circuit should be like this: minus, plus, minus, and then we have plus, minus, minus, plus, minus, and then we have a ZL, and another ZL over here, and then there's a short circuit between this point to this point here. Okay, so this is 120. So basically that's why this point to and this branch here and this branch here is basically the same voltage because of the short circuit here. Okay, so this, because the current is flowing like this, IAC, however the polarity, if you look at this, is going opposite of this, so means that the value of VAC over here, so this is A, this is C, this is a small letter, and this is C small letter. AC basically is negative 230 angular 120 degree. So negative because the current flowing is opposite. So this is goes like this and this is like this. Okay. And also the polarity lah, the polarity of the voltage lah. This is plus above, but the plus here is at the bottom lah. Okay, we just insert the value. Negative 230 angular 120 divided by ZL, which is 10 plus J8. So IAC, you will get a value of 17.9 angular minus 99 degree ampere. Okay, that's the answer for IAC lah. Okay, so for the next question, we need to find IBB, where BB is over here lah. Here B and the B capital, so the current should be like this, IBB. Okay, so to find IBB, we can use nodal analysis at this point. So we assume that the current flows like this, so we need to find IBA and IBC. So let's remove this first. Okay, so IBB equal to IBA plus IBC. Okay, so how we can determine the IBA and IBC? We can just refer to this circuit. If you look at this element here, ZL here is parallel to this voltage source, so we can say that the value, but first we need to put the polarity lah, because the current flowing like this, so the polarity should be like this, and this is like this lah, positive, negative, positive, negative. So IBA basically is the same voltage as this one, which is 230 angle 0 degree. However, the polarity is opposite. This is plus, this is minus. However, this one is opposite. The plus is at the bottom, and then the minus at the top. So the voltage will be negative lah. So the 230 divided by, which is the ZL over here is here 10 plus J8 plus IBC. So IBC is over here. So IBC basically is parallel to this voltage source. If you look at this point, these 2 points is connected, and this 2 point also is connected. So that's why this voltage source and this element here is parallel. And if you look at the polarity, if you draw it back, if I draw it like this, plus, minus, and we have another element here, which is plus, minus. So this is B and B capital, and this is C and C capital. So the point here is connected, so that's why it's parallel, and the polarity is the same. So it's the same value, which is this part lah, 230 angular negative 120 degree. 230 angular negative 120 degree divided by 10 plus J8. So if you push calculator, you will get the value of IBB is negative 30.75 plus J 4.68 ampere. Okay, so this is the last question that we're going to discuss. Find the line current IA, IB and IC in the three-phase network as shown in figure below. Take Z delta is equal to 12 minus J 15, and ZY is 4 plus J 6 ohm, and ZL, which is at the line here, is the 2 ohm. So we need to find IA, IB and IC. So how are we going to solve this? This is more like a combination of delta to V, right? So to simplify things, we're going to make both circuit network here to V. So this will be a V circuit, and this also will be a V circuit. And to find IA, we can use this formula. Okay, so this is delta to V. So we know VP, and we want to find IA, but however ZY, impedance of ZY still need to be calculated, because there's a combination of delta and V at the load. Okay, so first step, change to V, which we're going to use delta to V for source, V, for example VAB, sorry, VAN VP over sec 3 angular minus 30 degree. So VP, we already get this value, so we will get 254 angular minus 30 degree volt. And now to find the ZY, so there's a delta here, so we need to use delta to V for load equation. So to get delta to V basically is Z delta divided by 3 to get Z. We, for example, we put 1 here lah, because there's another ZY kat sini, ZY1. So Z delta is 12 minus J 15 divided by 3, you will get 4 minus G5 ohm for delta Y1. So basically this will be like this lah. So we have this is ZY, and then there will be another element, which is ZY1. So it is parallel to ZY. So Z total basically adalah ZY plus ZY1. So sorry, it should be not plus, it's parallel. Okay, parallel means you need to do the calculation based on the parallel value. So this 4 plus J5 parallel with 4 plus J6 lah. So Z total you will get 5.72 minus J 0.21 ohm. So from here we can simplify the circuit. So this will be 254 angular minus 30, and then we have a Z small l line impedance, and then we have a Z load, ZT lah. Okay, so to find IA, this is VAN. Can use formula IA equal to VAN divided by ZL plus Z total here. Okay, so VAN 254 angular minus 30 divided by, if you plus Z1 and Z line impedance, the line impedance is 2 and Z total is this value, so you will get 7.72 minus J 0.21, and IA you will get a value of 32.88 angular minus 28.4 degree. Okay, and then IB basically is IA angular minus 120 degree. Let me erase this first. So IA is 32.88 angular, so this you need to plus, so you will get minus 1 for 8.4 degree ampere, and IC is IA angular plus 120 degree, so this is 32.88 angular. If you plus this, you will get minus plus this one, you get positive 91.6 degree ampere. So this is as a value ampere. Okay, so that's all for this chapter tutorial. So next week we're going to discuss on the chapter 5, magnetically coupled circuit. Okay, thank you. Assalamualaikum.